Now it's time to show you how you can leverage automation and in order to achieve third-party integration. For example, if you want to integrate the software into your own tactical platform to achieve the desired outcome with minimal interaction and minimal configuration. So for this, we're going to use the API, the software's API, based on RESTful APIs. This is a web-based API. So the idea is to execute a task or a job remotely and get the outcome delivered to you. And let me show you straight the one potential use case, one potential integration. So I'm going to show you here Google Earth as example. Google Earth Pro. So here I pre-set up two links. One's called MANET before, the other one's called MANET after. Okay, so the one before is simply pointing to the API link with the specific key, specific ID for that job. So you've got one before, one after. They're both not working for now because we haven't done the computation. So the idea is to get the simulation outcome in that tool, in Google Earth, but it could be any other product. This is the command, this is the GUI or the interface where we can engage the software remotely using the API. So the idea is to select the server you want to work with and then select the job that you want to run. For example, I want to do a point-to-point analysis, or I want to do possibly search node in order to connect these clusters. So you can choose the job you want, select the digital terrain model you want to use from the server. I'm going to use the MANET, and I'm going to use a VHF, UHF radio or MANET radio, and I'm going to select the temporary record. I'm going to transmit the station parameters through the API as well. I'm going to use the vector polygon and so on. Now, this is permitting you to create a sequence of jobs. I've got job number 0, 1, and 2. So in the first step, I'm going to run coverage prediction, then I'm going to run search node, and then I'm going to run point-to-point matrix analysis. So this is point-to-point matrix analysis actually step before. This is the snapshot of the network before doing the search node, and this is going to deliver the snapshot of the network after doing the search node. So we're going to have two networks before and after optimization. And I already linked them with the IDs to produce the analysis correctly. So now all I have to do is transmit or send the recipe, submit recipe, and then you get a receipt, and then you can see the job is transmitted to the server. So I've got 3 jobs now just received on the server. Refresh. So you've got now one is running the coverage calculation. So let's go now together to the server and see what's happening. Here we go. So the server received the instructions and now he's computing the coverage in the background. So once this is done, it's going to move to the rest of the steps. So now you can see the point-to-point matrix analysis, which is the mesh or the MANET analysis, is completed. And now he's running the search node now. Now he's trying to optimize the network. This task will take a bit of time, but this task is already ready. So we could talk about it. Now go back to Google Earth. Let's see if it is ready here as well. Well, they are linked. So if it's ready over there, it should be ready here. So this is before, right click and then refresh the link. So now you see here it's a green, which means that it's ready. All right, so this is the mesh analysis, and that's with zero interaction with HTZ Warfare. So this is the analysis before is ready. Let me see if after now is completed or not. That will take a bit of time. So let me talk about this. So this is the snapshot of the MANET network before. So in this analysis, the software is producing a number of documents or number of outcomes. So let me shut down the routing. Here we have the mission units. The green circles here are the mission units, and also the red. Now the red are red because there is no command control they can talk to right now. These ones are green, which means they are mission units, and also it means there is a command control to talk to. Same with this one here. So the green links you're looking at are all the possible RF, so all the viable RF links possible between any two nodes. Now having connection here doesn't mean necessarily you're going to use it. If you click on this one, you can see what's the signal level for that link. You can see the length of the link, and also where is it running from to. From mission unit 3 to mission unit 7. Now if you click on the node itself, the node will tell you what's the node ID. It's mission unit number 5, and you can see there's only one command control within reach, directly or indirectly. So there are reachable CCCs are only one, which is MU1, and this is called mission unit 1 here. And here we have unique connections 4, so that node has 4 different connections out of it. And you can see how many hops to reach the gateway. So the RF links are, or the green links are all the possible layer 1 RF links. That's all, the whole list. Now the routing, so the routing also are divided into multiple levels, so directly. So these are the nodes that are connecting directly to the command control. These are the routes for the mission units that can connect with one intermediate node in between. 2 nodes in between. So you can see here, this one is specific for MU9, mission unit 9 to mission unit 1, which is the command control here. The software is calculating the shortest path. So it's using the green as a backhaul. Okay, so it's using the green, which is RF, to establish the optimum traffic route from that mission unit to the command control. And it's doing the same for the entire network. If you click on one of these red ones, it will tell you, it will list for you the hops is traveling through. So from 08, from mission unit 8 to mission unit 1, we have to go through 7 and 3 and 1. And he's counting the number of intermediate links in between. This is a perfect way to analyze if the network is performing well. And you can also zoom in, and then you can see the different highways here, or the lanes. So each lane means there's a traffic going through. So let's look at this one, how important it is. So you can see this one is passing two main routes. This one is probably also important. You can see how many lanes it's carrying. 3 lanes. The lower lanes are the ones that have shorter nodes to travel through. The higher the lane, the longer it is, so more likely for a distant node. Now let's see if this one is ready now. Yes, completed. The search node is completed. So now you can go back here, and then they say this one here. Let's refresh it. Hopefully it will be ready now. It is ready. So I'm going to shut down the snapshot before, and let's look at the snapshot after. So the new thing you notice right away are the blue nodes. These blue nodes are the range extenders. They are deployed in strategic locations. They are deployed within 50 and 100 meter buffer from the road center line. And they achieve the outcome we want, the desired outcome, which is to interconnect the different clusters and establish one big MANET network. So if you click on that guy now, you see he's a range extender type, RE. And if you look at the number of lanes he's carrying, you expect to carry too many lanes because he's interconnecting clusters. Here you go. So 1, 2, 3, 4, 5, 6. So losing that node means you're going to lose six links. So again, the green lines in the bottom here, they are the physical links, or what we call them layer 1, RF links. Now, not all the RF links will be used because they're not optimum in terms of number of intermediate nodes or throughput. So the ones that are used here are this one here, the top one, and then these two here. So this is pretty much what we wanted to talk about in this webinar. We hope you enjoyed it, and we didn't try to we didn't try to give so much explanation about what's happening. And if you have further clarifications, please feel free to ask during the QA session.